Hello and welcome to the AI Business Podcast, in which we're going to talk about silicon for artificial intelligence. My name is Max Smolaks, editor at AI Business, also known to his friends as Beast from the East. Joining me, as always, is my co-host Sebastian Moss, deputy editor at Data Center Dynamics, the premier destination for data center news. How are you doing, Seb?
Well, first off, not a single person calls you that, right? You put that on your byline for the 4 or so years you worked with me at DCD, and no one ever called you that. Secondly, I'm not doing great because I can't upgrade my computer because there's a global chip shortage, which is one of the things we're going to talk about today.
That is true. The price of memory is bringing a tear to my eye. We are going to talk about chips today and memory, and lending us his expertise on the subject is Rodrigo Liang, CEO and co-founder, I believe, of SambaNova, the startup which has developed a new chip and server architecture specifically for the needs of machine learning, or at least that's my interpretation of what they're doing, but I think the architecture might be wider than machine learning. We're going to find out about that. I probably shouldn't say this, but Rodrigo, you are the most high-profile guest on the show to date, so I hope this is the start of a new trend. But first of all, welcome to the show.
Thank you. Very, very happy to be here. Thanks for having me.
Yes, I guess my first question would be, SambaNova is a startup, a very young company with a high valuation. It recently reached unicorn status, but I would guess that you're operating in a niche market, and when you meet people for the first time, you need to do a lot of explanation. So what is your, standard canned explanation of what SambaNova does?
Oh, it's niche today because we're just kind of in these early days of artificial intelligence. But what we see is AI is going to take over the world, and this is kind of how the computing world is going to transition. And so what we think about in terms of computing is this transition of pre-AI to post-AI world is going to be as big, if not bigger, than the internet. And so every industry is going to think about how they're going to have to deal with transition. And what we're doing is building systems that allow us to help our customers transition over their processes and their products over to this type of technology.
And let's just set the scene first and talk about the chip market in general. Over the past 10 years or so, we've seen a decoupling of chip design from chip manufacturing. Fabless companies have always existed. I think Xilinx was one of the first, just design, no manufacturing. But now even Intel, which prides itself on making chips in-house, it just can't handle the demand and is now outsourcing some of its manufacturing. So there's decoupling. How has this enabled the AI market, and what has this meant for AI silicon in particular?
Well, the global semi demand is definitely shot up. I think the fact that the technology nodes are getting smaller and smaller, they're getting harder and harder and more expensive to produce as well. And so it's great to see, as a chip guy that's been around for 25 years building chips, it's great to see the demand of chips and chip design to come roaring back. But it does put some pressure in the market. And so what it means is all of us just need to do a lot more with the silicon we do produce, right? And so you think about what is the IP that goes in there, right? You're moving wafers through fabs regardless. And so you got to think about, what is that IP you put in there? What is the software going to run on top of it? And how do you get as much value as you can out of every chip that comes out of that fab? And so this is going to be, fabs don't just pop out of nowhere. These are multi-billion-dollar investments that companies have to put together to build these fabs. And so this shortage is not going to be something that's going to be fixed overnight. So we all, as producers of technology, need to think about when and how do we use the silicon and how to get the most value out of it when we actually produce these parts.
What does the shortage mean for smaller customers? The NVIDIAs, they can say, look, they can call up TSMC. I'm sure they have a whole team of TSMC people who listen to them. The smaller guys, I've spoken to a few, and they've said, TSMC, we don't even know who to call. We can't get on their radar because we're just too tiny. They're churning out literally hundreds of millions of chips. There's some rumors that pretty much all of the 3 nanometer chips have been bought up by Apple before like a couple of years in advance. Well, as a smaller company, how do you make sure that you're not caught up in this great shortage?
A lot of it has to do with planning in advance. We've pretty much since the beginning of last year, we've pre-purchased most of our material, and so you just have to go ahead and prioritize that investment early and make sure you get into the fab early. Now, think about these big companies; their needs are very large. These are the boulders that go into the pipe, right? But in between, there's lots of opportunity for pebbles and sand to go through it. And so, depending on demand size, you still have opportunities to do that. So I think if you're a company like NVIDIA and Apple and some of the other ones that have great demand, you have to plan in these coarse grain buys, right? And so you have to plan much further in advance. For smaller companies, your needs likely are smaller. But even then, you have to figure out how to actually plan way in advance so that you can actually get into those little windows that are available for us to purchase parts.
So you've not seen any delays with your products or not been able to meet demand because of the chip shortage?
Correct. Yeah, we did ours way in advance, and so we're in good shape right now. But again, our aspirations are also to grow to put pressure on the operation side of the business, and so you want to be in a situation that you're selling and you're actually creating that tension. But for the moment, we're in good shape.
So this state of chip shortage and just issues with silicon production, do you think it's a temporary blip on the radar? Do you think we can fix this, or this is shows the shape of things to come, where it's just like there's going to be more demand, the production is not going to be able to catch up as quickly, and then there's the question of technology in terms of the actual process, right, and the resolution of the process. So do you think this is temporary and everything is going to be fine again, or this is more a long-term trend and we should learn to work around it?
We'll catch up. Like I said, I think these fabs, they're not impossible to build. I mean, these are things that we can build. It's just they're just very expensive, and so you have to give it some time for companies to come in and be able to put together these factories that are able to produce at this level of capacity. And so I think what happened over the last 2 years is suddenly there was a surge of demand, when for many years prior to that, it was pretty modest, right? And so you didn't see a lot of companies investing heavily into these fabs because the silicon demand was fairly modest during that period. But suddenly the surge, you can't quite catch up with whatever infrastructure there is. And so you're starting to see companies and even governments starting to get involved and say, how can we help fund more factories to meet this need? And so you're going to see that start catching up over time. Right. And I mean, as a chip guy, it's great to see the demand, and you hope that it's going to be, a rocket ship that continues, but that's just unlikely. I think you're going to see the surge get to a new plateau, and that's going to grow at a more predictable pace. And then at some point, the factories will catch up.
Yeah, I think to put into perspective for listeners, pretty much every major automotive manufacturer has had to idle plants and had to say, we can't produce cars because we don't have the chips to put in them. And they're the extreme, but people can't buy PlayStations, they can't buy Xboxes because it's just there aren't enough chips. One of the things we're seeing in the US is this push to try and have domestic manufacturing. That's both this immediate supply chain issue and the broader kind of trade war and Cold War with China. What are your views on the various kind of proposals going through government at the moment? Biden said he's going to push for a $37 billion fund to help things, but that's almost a drop in the ocean when it comes to fabs.
Yeah, these fabs are expensive, and I think more and more it's becoming something that's of national interest for different countries. And so, you expect countries to actually make sure they're finding ways to protect their national interests. Chips are everywhere; they're everywhere, either for like you said, your cars and gaming, but also in every aspect of our lives. And so you think about what the government wants to do is just to make sure that there is enough options for people, so that if parts of your national interest is to build things that you want to have made in this country, then you have to have options, right? And so these are very expensive investments that have to be made by corporations, and so more and more you see corporations move away from that because they just can't make sense out of investing that much money. And so I do think that countries are going to start thinking about how to help to actually give them options. I do still think that this is a global industry, and companies like ours are going to be selling globally and building globally because that's just what we need to do. And so, but there is going to be a push, not just in the U.S. but other countries as well, to actually figure out options that allow them to actually manufacture them locally if they choose to, because it's of national interest.
Yeah, because I mean, between TSMC and a bunch of the kind of smaller players, Taiwan is responsible for more than 70% of chip manufacturing. And they're going through a water shortage at the moment. Those manufacturers are having to truckloads of water coming in because they don't know if they're going to have enough water. You've got the country, technically, China thinks they're in a civil war. Taiwan doesn't. It's probably good for everyone to not have something so crucial to the global economy primarily come from one location.
The climate alone in Taiwan. Do you remember the great hard drive shortage we had maybe 5-6 years ago when there were floods, several factories flooded, and the whole world, like the prices for hard drives just shot up because yes, you made all of your things in the same location and it was hit by a natural disaster. What did you expect?
Yeah.
Yeah, but I can see how we arrived there, and TSMC has just been phenomenal in the way they actually operate and build chips, and they do it better than anybody else right now when it comes to high volume production. And so they've done a great job, and it's an expensive endeavor. And so if you're not doing a great job, it's hard to survive, right? And so you can see how companies like that do become dominant, and everybody wants to go there, because they're the best at doing that, right? And so we've seen it happen in other industries where it just concentrates on kind of who's the best in doing a particular thing, and then economically, I think it becomes something that the demand side wishes there were more options, but it's a very expensive and very difficult thing to do, and so getting other players to play is always been a challenge when it comes to building fabs.
Yeah, I think for those maybe in Congress who think you can just kind of throw money at the problem and it will go away, you can look at how China has tried to emulate TSMC, and they've tried to have their own fab industry, and they have pumped billions, spent years, most likely committed some IP infringement, and it's not worked. They recently opened a company, a very well-funded fab company, opened and then shut immediately. It's an incredibly tough thing, and you can't just ramp it up like a lot of other factories.
I like that. I think this is kind of where we come back and say, hey, when you're thinking about chips and building your business around it, companies like ours, we start thinking about how to get more value out of these, right? Because if it's just about throwing more chips at it, then it becomes you continue to perpetuate the demand issues that we're seeing today. And so what we try to figure out is, not only do we ship a chip, but we ship a system with applications on top. And so actually, when we actually deploy our chip technology, we deploy it as a subscription service to people, right? And so we come in and we say, we'll give you a natural language processing service or a high resolution computer vision service, because that allows us to maximize the value that very high demand silicon can provide to the end user. Right, so that's kind of how we think about it, and try to make sure that we turn that value into something that users can actually consume very quickly.
So how does this approach translate into technology? So you've created the Cardinal chip. Is it the density of the transistors? Because I think they're just like big sizes, pretty much maxing out the kind of the capabilities of the printing process. So what makes Cardinal special, and how do you implement some of the things you talked about? Like this idea that like silicon needs to be useful, it needs to deliver value. How do you implement that in hardware?
Yeah, so what we ended up thinking about was, if you think about every architecture that we've built over the last 30 years when it comes to CPU design, it's all been very instruction focused. We think about things about adding, subtracting, and we spend a lot of time with the instruction side of the world. And as you know, with computer architecture, there's instruction, there's a data, right? And so with the immersion of AI, and actually even prior to that, big data analytics and large data type of operators, those are all very data intensive type of workloads that what you really need is something that's much more data centric from a computational perspective. And so what we did with our silicon is create an architecture that's DataFlow. So thinking about how do you actually optimize for data, how do you actually control where the data actually sits, and have the data show up when you need it, where you need it, right? Which today you actually have very little control of exactly where your data ends up going. You want to add or subtract something, your data gets sprayed in all sorts of caches and DRAMs and things like that. And so you actually don't know exactly how many copies of that data you created just to do a particular operation, right? And so for SambaNova, what we decided is to flip this thing on its head and say, no, let's create an architecture that's focused on data as it moves through the machine, because the operation is an iterative operation that needs the data to actually continue to actually move through a system, right? And so when you create an architecture like that, it allows you to most seamlessly operate this type of workload without having to actually incur more costs sending to other chips like memory chips and storage chips to store this data, and then have that come back and forth with the computing engine.
Right, so that's why you can't, like, if podcasting paid better, I couldn't buy a Cardinal chip just by itself. It has to be part of the broader thing.
Yeah, I mean, today that's where things are at today, because it allows us to actually provide value to the end user faster, right? Over time, you would expect standardization to come in, and people will start normalizing on what the programming model should be for these types of things, and creating applications on top of it that are designed to a certain API. But today, because it's still early days and evolving, what we try to do is encapsulate the whole technology into something that you can use, like an NLP model, or like a computer vision model, or if you're doing recommendations or whatever it is, right? And so that we capture that service to something that people are already using today. You can come in and sign up with our system, and you're up and running within the hour, right? Doing something that you're already doing today. Right? There's no design and process. There's no programming, importing. There's none of that work. You just come in, you use our service, and then you're up and running.
Okay, so can you buy the hardware without the service, or does it always come as a combo as a service? Like you run the SambaNova software on top of SambaNova hardware.
Yeah, sure. We sell the system as well. It's called DataScale, and you can actually buy a server and stand that up and run a variety of models for you. And so we certainly have customers that are doing that today, and we have use cases out there where people are doing, where one of our systems is used as part of the COVID research by the Department of Energy activity in the United States. And so we certainly do that type of work as well. And then as you broaden out to other users, some people, they don't want to actually manage these large systems themselves. And so they come in and say, well, can I just do a computer vision type of model on your service, and do it in a way that you cannot do today. One of the things I was telling people is, people don't realize that actually the resolution that we can train images today is actually low def. It's actually, the pixels, we can only train these, very low pixel type of images today. And for something like AI, you would think that you'd be in like ultra HD, ultra HD, you'd be high res. And so we now have a system that allows you to go and train images that are 10K by 10K pixels, or even more than that, and so and take them natively at that image without having to downsample, which is what you have to do today. In most systems, that you have to either blur the picture, and downsample them, or you actually have to slice them and then train them one piece at a time. And so those are the types of things that we were super excited about that we can do today that others can't, and allows people to have these whether that's medical imaging or other type of really satellite images, or various different things that people want to train on. You can't do it without a system like this. And so you can very quickly sign up with our service, and you're up and running.
One of your investors is Intel. The DataScale use an AMD EPYC RAM chip CPU, right? What was the decision behind going with AMD?
Well, yeah, so Intel Capital has been a great partner, and it's been an investor from early days. But when it comes to our products, we're just looking at what fits our product needs. And so at the time, with AMD, their I/O interconnect was what we needed for the architecture that we had, and so that's the technical choice that was made. Although I think it's as Intel's roadmap continues to move ahead, I think they're providing the same level of bandwidth that we need for the I/O side. And so it's the choices inside the box are made just based on kind of the technical needs of the architecture, of the system architecture as a whole.
And you mentioned the importance of data and the importance of memory. So obviously, like, yeah, the fastest you can process data on this chip, the second fastest is in memory. And then based on what I read, like, memory is very important to data scale. So could you explain? Yeah, because I think based on what I've read, you just have more memory than pretty much any other comparable, like AI training setup. So yeah, could you expand on that?
Yeah, absolutely. I think it comes down to kind of what your computing model is, right? Today, if you look at the model and the data, it resides with the host. Typically, resides with the x86 host, and then what's done then is, as the kernel needs to be computed, then you are carving that and sending it over to some accelerator, right? You're sending it to the accelerator to compute that, and then the orchestration of it is done through through the host. On the SambaNova side of the world is we think about this in terms of taking a coarse grain model, moving it all over to SambaNova, right? And this is why we have a lot of memory directly attached to our chips, because we can orchestrate. Our belief is we can orchestrate that better than having it through somebody else, right? Because we understand how the models need to be optimized, and we can actually then parse the models, parse the data, and make sure the data sits where it needs to sit without having the constraints of a different operating system, a different runtime coming in and actually spoon feeding the data one piece at a time, right? And so that's the way that we think about the model, that we want a lot of data sitting next to us. And then what you really need is you need to actually have a balance between the different hierarchies of memory, right? As you mentioned before, you need very fast on-chip memory, and you have to have the right amount in the right configuration on chip, because anything you can keep on chip is significantly faster, significantly more efficient than anything that goes off chip, right? But as soon as you do go off chip, you want flexibility in how you manage the model, not just for performance, but also for the programmer. Right. What I've seen around the last just few years when I'm talking to people, there are a lot of software programmers who do not appreciate that they have to go in and understand the bowels of the chips and understand where my memory needs to be managed and how do I put my code here and there, because if I don't put it just exactly in the right place, the performance drops, right? So we're trying to do away with much of that so that it makes it easy for you to program. Right? Our belief is this AI transition doesn't happen if you make it so difficult to program these applications, right? So you want to make it easy. You want to actually have plenty of flexibility, allow the user to program in a variety of different ways, and still get very good performance coming out of it. And so, so that's kind of what we've done. We've allowed you flexibility within on-chip memory, very fast, allowed you a very large off-chip DRAM attached directly to our chips that allows you flexibility in how you program, and then if you need beyond that, then you can spill over to the host and other places because it's part of this bigger system, right? And so that's kind of how we think about it.
I mean, not to bash on about NVIDIA too much, but on the software side, is again, they've tried to lock that down by, they have an enormous software team trying to create software that either locks researchers in or just gets them really used to NVIDIA's tools and software, and they're more likely to use it just from convenience. How do you compete with like a Goliath like that?
All that customized work that locks you in, right? And as far as I can tell, most customers don't like the idea of being locked into a single vendor. And so what we try to do here is operate at an open standard. So we go up to a PyTorch model, for example. Most people are writing PyTorch, TensorFlow, or some abstracted layer. And so we just take the graph at that level, and beneath that, we have a stack called SambaFlow that automatically converts that over to code that you can run. So you're not coming in and doing any hand tuning, hand kernel writing. You're not doing any type. We don't send people to classes to learn how to do a SambaNova coding practice or whatever. We don't do any of those things. You come in with your standard code, whether that's PyTorch or TensorFlow, and then we actually just map that straight down through the SambaFlow stack. That's automated. And so all the section cuts that you have to do as you think about kind of how to map these things to multiple chips, all the different optimizations for bandwidth and latency, and how do you actually take the kernels and map them through the system, those are all done automatically through our software stack. And so that's one of the beauties of this, is just saying, hey, why don't we just move away from all of this hand coding of stuff, right? And just move away from that and just have the programs operate at the framework layer and above, right? That way, whatever you created there, you can leverage over to any other platform. You know, one day, if you don't like SambaNova's hardware, you can move it over to somewhere else, and you didn't invest all this energy creating software IP underneath it, right? In a way that you have to do it with others today, right? And I think that that's going to be more and more of a barrier for people to think about, well, do I really want to invest all of my engineering kind of locking myself into this particular solution, or do I want to operate at this high level and require the vendors to say, show me performance without me having to invest all this manual energy tuning for it, right? So if you can do that and say, hey, my number one requirement is I'm going to come onto your platform, but out of the box, show me performance without me having to do all of that work. Now you just change the game. You put the control back on the customer and back on the buyer and say, let's elevate every customer to be automated and play on fair playing field. And everybody just automatically generate out of the box performance that allows the customer to just pick and choose what's the best solution for them at any given point in time.
Okay, so one of the things I read about DataScale claimed that you guys have like virtually unlimited scaling. You know, like you can plunk as many of these devices together as you want. So, and some of the features you described are kind of enterprise-ready features. But what about DataScale for supercomputing? Are you interested in this space? Are you working for this space? And it's just like if your scaling works as well as advertised, does that mean we can expect your systems to appear in, you know, like top 100 for AI and then top 500?
Top 500.
And and similar kind of rankings.
Yeah, well, I mean, you see some of our earlier customers that have been willing to talk publicly about what they're doing with us. I mean, they have systems ranked in the top 100 and top 50, right? And so you look at the Argonne National Labs and you're going to Lawrence Livermore National Labs. These are institutions that have historically built very, very large computers, and some of the things that we're doing certainly are in line with being able to support systems like that. But I mean, these are things that our partners actually do, right? And, you know, for example, we provide the infrastructure for them. We want to be sure that we can actually scale it to a certain level because that is the demand, right? You look at some of the hardest problems they're trying to solve. These are going to be many racks of servers for one model, right? Not as a data center, but for one model, it's many racks. And so that's part of why we create an architecture, system level architecture that can scale like that, because these problems are growing and growing at an exponential rate, right? And we seem to have models that are growing exponentially. We have data sets that are growing exponentially. And so the two dimensions growing like that, you need systems that can keep up, and starts with a node. Our racks is a very powerful node. And so it starts with racks that are very powerful, and then you can scale them in a proportional way. That's one of the keys that allows us to scale in this way, because per node, we just have a lot of capability.
But I'm afraid this is everything we have time for today. Thank you much, Rodrigo, for talking us through it, and good luck in your work.
Yeah, Max, Sebastian, thanks for having us, and yeah, looking forward to connecting you down the line.